Okay, take an example of, let's say, a milk delivery app. Yeah, so all of us like consume milk, and we might have somebody to deliver that uh, product to our doorstep. Okay, so what are the things, if I look from a business perspective, what are the different stages of when it comes to delivering a milk product to your home? Yeah, first is like you log on to a website, order it. Yeah, you order the food. Now, once you order is received, the order might be delivered by some vendor, sister concern, and so on. So order goes to another vendor. The based upon your order details like the size, yeah, the type, yeah, and the quantity is packed. Okay, you do a packaging, and once this is done, it is then sent to a delivery partner, and the delivery partner will take the details of the order, yeah, the address, the contact number, the location, and all those things, and then deliver the product to the customer. All these are happening via a digital kind of a asset, which is nothing but your application. It can be your mobile application, it can be your web application. Everything is happening behind the scene, and some sort of a task delegation is done behind the scene. Yeah. Now, have you ever thought what goes into all those things which is happening in the back end? Anybody? Hmm? Okay. So, just like this, we have our application delivery cycle as well. Okay. Software application delivery cycle. There are multiple stages with which we will interact when we are trying to build a application and then deliver it to the end customer or the end user. So just like that, we have to follow certain practices which will help us to actually get the product to the customer in a faster manner. And that's where DevOps plays a very critical role to deliver your application to the end customer in an efficient manner, in a correct manner, as well as in a right manner. Hmm? So, so DevOps, yeah, is nothing but a kind of a practice, as a framework which is used for delivering application to the end customer. Yeah, it can be in terms of the services, in terms of any usage of their product also. But what are the different problems which are actually faced when it comes to delivering a application or a software to the customer? Okay. So whenever we are trying to build any application, any software, we need some sort of a underlying hardware. The underlying hardware is going to be the key component on which it is going to be built. Yeah, so this is the server. We will need a server. At times, we have to depend on a IT person to get the server ready for us, install the right software on top of it, and then you start your application development. Yeah. Okay. So as you can see, there are multiple stages and there are multiple dependencies. The delivery of that particular application can be slow and can induce some error due to manual intervention. Yeah, if we have manual intervention where I'm depending on an IT person, then that person will take care of the software installation, and then somebody will just write the code. Okay, so there can be a slowness in terms of coordination, in terms of getting the things done when it comes to delivering a software. And because manual intervention are there, it can have some errors. Because we are interacting with humans, because we are interacting with different teams, there might be some different roles and responsibility of this, and there will be a kind of a wall in between how they are working, and that can create a friction between the different teams in terms of what is they have done right, what the other team has done right, and so on. All that can consume lot of time. Yeah, it is going to consume a lot of time, and that time consumption can delay your project, and that delay can translate to money loss. Hmm? Okay, so in nutshell, what we are saying is that there can be a problem, there can be a bottleneck when we are trying to deliver our application to the end customer. Okay, so those are the different things which can plague any software delivery lifecycle. Okay, and some of the symptoms you might see is like inability to diagnose any kind of issues early in the life cycle. Okay, there might be different environment, for example, test, yeah, dev, yeah, and the production environment. We'll see what is this. That the issue might be not it is working properly in test. It might be working in the dev, but it might not be working in the production environment. Okay, so issue can be in certain environment as well. Okay, when we are actually delivering the software, we are testing it under different environment, and there can be certain defects which can get released from one environment to the other. Yeah, it can pass from here, it can pass from here to here, and directly to the production. So because of that, it might happen that you might face some challenges causing some outage. Okay. And again, a natural outcome is to do a finger pointing or blaming anybody. Hmm? Okay. There might be certain teams who are going to actually, yeah, do thorough testing on it. And that can add to a long delay, yeah, and so on. Okay. So these are some of the symptoms of the problems which are there in every life cycle of a application development. Okay. So net and net, if I want to see that issues, why they are occurring, it is because of some of the misalignment between the business and the IT. Yeah. And at times, business might demand a very fast thing to be delivered, but it might have some kind of a risk and it might be very, very cost sensitive. Okay. Again, when we are building, we can have a different view in terms of building a particular kind of architecture. It can be a kind of a monolithic architecture. It can be a way of managing everything centralized. And at times we become, yeah, penny wise and pound foolish, where we are focusing some trivial problem, but the major problem is left unattended. Okay. And at the end, everybody demands that we need to innovate, because why? Because we are humans. We have to give a unique solution to each and every problem. And at times, your house can be on fire because of those innovative things you can try, yeah, or innovative things you can do. But again, that's not the outcome you are expecting. Then how do you streamline it? How do you get the things in a right order, right manner, yeah, and so on. Okay, any question in terms of what are the different problems which are there with a software release or application release cycle and the different symptoms? Any question in this? Hmm?
No.
No? Did you understand what are the different challenges we are facing when we are actually trying to work on the particular application development cycle? Hmm? Anybody? No? Okay, fine.
No,
So
sir, no
who,
issues.
okay, so now who can help you in the such kind of a difficult situation? How do you, yeah, overcome this kind of a situation? Yeah, definitely we might need a superhero. Yeah, we are living in the era where we have superheroes for each and every cause. Yeah, who might be that superhero for you? Any guesses? No? Batman, Superman? No? Okay. Yeah, we can call it as the DevOps person. Yeah, the DevOps person can be of a prime importance when it comes to actually sailing through the complete life cycle of your application development. Yeah, and that can be a superhero to rescue from all the challenges, hassles, issues, and so on. Okay, do you agree with me? Do you feel that we need superpowers to be able to deliver a application? Okay, I in practical, I don't assume that we should have those superpowers, but yes, we need to understand the nitty-gritties and so on. Okay, few of the stats I want to share when it comes to usage of the DevOps. Yeah, DevOps as a global market is widely huge market. Yeah, and which is which is close to around 25 billion. Yeah, expected to be 25 billion. Yeah, and which is going to be in 2028. um lot of times, yeah, organizations says that yes, they want to actually build on their DevOps practices. 80% organizations say that they want to enhance their spending, their DevOps practices. Yeah, and okay, and lot of companies, yeah, they are comprise of different metrics which will help us to improve the developer productivity. Yeah, nothing but in terms of the Dora metrics. So all those things are some of the stat which are actually very prevalent in the market, which is highly visible in the market. And that's why learning DevOps is one of the critical part in any software delivery cycle. You as an individual have to master those things to get to the end of the tunnel. Okay, so let's look at the definition of DevOps. Yeah, this is the term which was coined by Patrick Debonis in 2009. It is nothing but a collaborative way of developing and deploying software. Okay, it's a method where you collaborate, yeah, you integrate, yeah, and communicate efficiently between the developer, software developer, and the IT person to do the different task. Yes, we've seen the example of that milk delivery app where we are dependent on somebody to build the server for us, install software, and then write the application code. So these are the different personas which will be part of a DevOps. Yeah. So when we work as a DevOps, we don't live in silos. No, we don't live. We have a clear collaboration between each of us. Yeah, we work together. Yeah, and we work better. We think alike. Yeah, and we break down the silos. In doing so, we have shared responsibility, which will help us to achieve a common task. Hmm? That is nothing but a DevOps. It's a framework, it's a mindset which helps you to navigate the challenges which you face in a software release cycle. Okay, so has anybody read a blog about Netflix for um, their one of the very famous theory they have coined, which is nothing but the chaos engineering, and they call it as a simian army. Anybody heard of it? No? Okay, I would strongly suggest that you go and search the Netflix block of Simian Army, which where they have defined what is chaos engineering and how you can do some kind of um, what you can say gamification of your environment to actually make it more robust, resilient, and so on. Hmm? And those are all built on the principle of DevOps. So DevOps have different principles. In DevOps, we follow different practices, and to achieve that, there are multiple tools to take you through the line. Okay, so we'll see some of the principles. Okay, what are the principles? We believe in the DevOps, we believe on the CAMPS principle, where culture plays a very vital role, driven by the people who are going to use by following certain processes and leveraging the various tools which are at your disposal. One of the very critical and important aspect when it comes to DevOps is focus on automation. Automate whatever you can to reduce the human dependencies, to eliminate the human error. Yeah, automate whatever you can to actually get the things over the line without human errors. Hmm? So then whatever we are doing, we have to measure it out. Yeah, measuring the things is one of the very critical thing, because that is going to help us to actually improve on whatever we have done in the first iteration, second iteration, third iteration. DevOps is all about iterating and improving on it, and that can be done by measuring the things and then improving on it in a very, very quantitative or qualitative manner. Again, nothing can break or nothing can replace the collaboration we have to bring between the IT people and the software developer. That is nothing but the DevOps principle on which it is built. Okay, so what do you need when it comes to DevOps is the change in mindset. Yeah, change in mindset along with the various tools which are available, and that will help you to navigate the modern application which is very, very fast paced. Yeah, any questions in this? No? Fine. So let's go and look at some of the practices which are being followed. Few of them notable practices I will just touch base is nothing but a version control. Now, whenever I am writing any kind of a code for my application, what am I doing? I am writing it on my local machine and then improving on whatever I have written. Okay, so having a version control system where you can fall back to the previous better version or to a version which is an error prone is a very, very critical. So any application which you are building needs to have a version control system for your software code. This version control system will also help you to have a collaboration between different teams. How? You will work on one piece of code, another team will work one piece of code. Both the teams are spread across the geography and you are going to collaborate with each other. When your piece and their piece is ready, you can merge that piece and have a complete software, and that can be achieved by using some sort of version control system or SCM, control management tools. Okay, anybody knows what is any example of SCM or version control system? Wonderful. Any other name which comes to your mind? Yeah, one is Git.
Jira.
Okay, no.
GitLab.
Okay. Okay. I would say no, means GitLab is fine, yes, but Jira is no. Okay. So there are many things which are there. Okay. And you can actually utilize the different version control system. Okay. Fine. Then other thing which I have all made sure that we have to follow is nothing but a proactive monitoring and metrics. Whenever we are actually doing anything, we have to have a proactive monitoring in terms of whether I am getting a 200 okay, yeah, or there are some 4xx error or 5xx error. Yeah, that is going to help me understand where the issues, how do I resolve those things. Okay, whether my machine is utilizing the right amount of CPU, memory, and so on or not. Is my application is able to cope up with the amount of traffic which is coming to my environment? Am I having the right fit for purpose infrastructure to support that? Whether I need a GPU, whether I need a CPU, yeah, all those can be monitored proactively based upon different metrics which are generated in the system. Then, whenever we are building an application, we need to do some sort of a testing on the application. Yeah, whether it is working as expected. Are there any challenges on my application which I have delivered? So you need to create a unit test cases, yeah, and do a testing, functionality testing, feature testing, and so on. Okay, so having a right testing or the quality QA framework is going to help you a lot. Then you have to have a tool chain approach where you are having one process after another, yeah, to take care of it from here to here, from here to here, and so on. This kind of a tool chain approach will help you to actually navigate to a complex process in a much systematic manner. So in first case, I can do something in terms of, let's say, testing. Yeah. Then I'm going to build my environment and then I'm going to deploy it. Okay. So need to have a tool chain approach to do the things. One of the very, very crucial thing which has happened in the recent past is the adoption of the cloud environment, adoption of the virtualization technique, which has really accelerated the DevOps practice. Okay, use of various cloud providers, AWS, Azure, GCP, and all those things have really helped to try many things. Yeah, fail fast, and yeah, innovate. So utilizing the virtualization technique, the cloud providers is a key component in a DevOps practice. Then comes the CI/CD part, continuous integration, deployment, and delivery, where we are actually trying to integrate whatever the changes which we have built into our software code and then delivering those to the end user. Okay, so these are the different practices which are being followed. I will not go into each and every of them, but these are the things which are very, very critical for the success of your DevOps pipeline. Hmm? So, any questions, queries on this? Are you able to understand what I'm saying? Yes. Okay. See, if you are not able to understand, please raise it out. If you don't raise it, it's not going to help you only. Um, because I could see people from across the geography. I will not use the local language, but I'm comfortable in local language as well. Okay. And don't hesitate if you feel you want to ask something, just unmute yourself and ask it. So let me go to the next slide. And this is what are the tools which are going to help us to actually navigate the practices what we have seen. We have tools which will help us to actually deploy the things, yeah, monitor the things, test it out, build it, yeah, and even have some kind of a version control system. Okay, so you can see here we have Ansible, Chef, Puppet. These are all configuration management systems. Yeah, or you can also use it as a ISE. Okay, then you have the monitoring like Splunk and NGOs. There is Prometheus and Grafana as well. New Relic, Datadog. Then we have for the release, yeah, CI. We have the Jenkins, Bamboo, Circle CI, and so on. For the build, we have for the Java, we have Maven, Gradle, and for the testing, JU need Selenium. And for version control, we have the Git and Subversion as well. This is nothing but the complete uh, cycle in terms of when we are trying to build
Sir,
our code. Uh-huh.
sir, in the DevOps tools that you just told of release and all, so what are the best specific tool we should use for any four of them for testing,
So,
releasing? Yes.
okay, okay, let me use a different color and highlight those. Okay, these are the essential tools you have to learn. Yeah, uh, these are the essentials tools. You can have this both of them. Okay, then this. And there are certain other tools like Terraform. Okay, these are the tools you should learn, and this one, Prometheus and Grafana as well. This, if you are able to master all those tools, then other things will be very easy for you to actually grab. Hmm?
So, sir, which is better, Kubernetes or Docker?
Both are different. Okay, so this is an orchestration tool. This is a container technology.
So coding
Okay.
is important, sir.
See, don't be afraid of coding. Nowadays, it has become so simple for you to do the things with all the coding assistant tool which are there in the market. As a kind of a DevOps, you need to write certain snippets of codes, certain small script to get the things automated. For example, if I just want to build a small infrastructure, what I do, I write it as a code in a Terraform. Okay. So there you will need the knowledge of basic shell scripting and yeah, YAML or JSON. So it is not a mandatory, but then if you have those skill set, it helps you a lot.
Okay, got it. Got it.
Okay, so you are not going to do the hard complete kind of a application coding, but yes, you need some knowledge in terms of the scripting language like shell script. Yeah, uh, Python is widely used for a lot of automation and so on.
So
Okay.
Python basics will be
No, we are not going to cover. We are going to cover shell scripting. Yeah. And we are going to cover Linux in our
Linux.
class. Yeah.
Well, I'm
Yeah.
from DB end, so that's
Huh.
why.
Yeah. Yeah. So no, we are not going to cover Python because Python itself is again a different altogether a course where you have to just go through multiple things. Yeah. So we are not going to cover. Hmm?
Okay.
Okay. So yeah. So coming to the different stages in the complete life cycle of application development, you as a developer are going to write something, write a code, and once you are verified, once you are ready that my code is good to be used, then you do a commit. Yeah, you do a commit and then store it in a source control system. Use that code to build a certain environment. Okay, run some testing on top of it and then deploy it that environment. Okay, then whatever the expected output, you, for example, you want to just test 1 + 1, what is this? And if you are getting expected result, then well and good. If not, you iterate this process again. Yeah, so it is just a iteration. You just follow the iteration and then it will be in a kind of a loop. Okay, this is nothing but what you are doing is connecting what? A a following a complete CI/CD process. Okay. When it comes to continuous integration, what you are doing is you are just committing any changes, building it, yeah, and you are building as soon as the changes are committed. Okay, this is nothing but a continuous integration. We use tools like Git, where we are able to collaborate with different teams spread across the geography and work as a single team, deposit the particular code into your source code repository. Okay, so which allows, what is CI? A process which allows multiple developers to work on the same code or repository and making sure the integrity of code is maintained. Yeah, that is nothing but your CI. Okay, what are the major things you want to achieve? You want to achieve that you don't have any bug in your code, the software quality is maintained, and it is going to help you to reduce the overall time to validate and release new application software. That is the use of your CI. Okay, now what is a continuous delivery? Continuous delivery is nothing but additional step when you are trying to deploy your application and use that for the for checking on the different changes which are built by your the particular application code. Yeah, so you automatically build it, test it, and deploy it based upon certain human intervention. Yeah, so you see whether the piece of code is right or not. If it is right, then only you go and deploy it. Okay, this is nothing but the continuous delivery where you are building, testing, and then preparing it with the for the release. CI CD is tightly coupled. You integrate your continuous delivery with the CI to deploy the various code changes and deliver the application to the end user. Okay, again in this continuous delivery, okay, yeah, what we looking at, one way of doing it fully automated, and the second way is to have a partial automation in place. Okay, then we will look at continuous deployment. Okay, in continuous deployment, as you have noticed, in continuous delivery, as you have noticed, there was a manual intervention at this junction. Yeah, there was a manual intention which was not allowing us to deploy our application code. But when we do a continuous deployment, we do not have any kind of a manual intervention, and it is a completely automated process. Okay, so any thoughts in terms of what is best, whether it's continuous delivery or continuous deployment, which of them is best when it comes to delivering the application software to your end user? Anybody want to answer it? No?
Jenkins.
Huh? So
Jenkins.
no, not Jenkins. I'm asking which is better, continuous deployment or continuous delivery?
Continuous deployment.
Okay. Any thoughts?
both
Anybody
are
else?
both are tightly coupled. So without
Okay.
continuous build
Okay.
or like it is not like
Okay.
good.
Okay. Fine. So automation is at times good, but then when it comes to your production environment, you should not go for continuous deployment. You should have some sort of a manual intervention to check whether the code is right, whether it is written in the proper way or not. Are there any kind of a testing done on that or not? And then only it's deployed. So for a production environment, continuous deployment is not the right approach. Yes, for lower environment, continuous deployment can be a right approach. So for production, you can have a continuous delivery, but for lower environment, you can have a continuous deployment. Okay. So with that, we will stop here, and I will end my session for today. And if you have any queries, questions, I am here to help you out. Any questions? Any queries?
Difference between continuous delivery and continuous integration.
What?
Difference between both CI and C.
So what is written here? You have to have a decision making. Yeah. But when it comes to the continuous deployment, there's no approval required. Everything is automated. Okay. Suitable for testing environment and not for your production and continuous deployment. But continuous delivery is good for the lower environment. Yeah. For the production environment. That's the major difference. Come on, you are not asking many questions. Okay.
Sir, in
Le-
continuous integration, if there is any fault or error in the code, then is it recognized as a very blunder mistake?
No, it's not a blunder. It's not a mistake. Yeah, that's why we test it out on the lower environment. We check it whether it is working as expected. If not, we change it. That's why monitoring plays a very important role, where you are going to check based upon whatever you have done, is it working as expected? If not, you change it and you again deploy it. That is all the gist of the DevOps. You keep on iterating the process till you get the right result. Okay, so there's no kind of a blender or anything, because you try, experiment, and then you succeed. Hmm?
Oh.
Okay. Yeah. Others? No? Okay. Okay, then that's fine. Okay, that's it for today. Yeah.
Hello.
Yeah. Tell me.
Hi, sir. For example, if we become a DevOps trainer, means what will be the, designation as a DevOps engineer or DevOps admin? There are a lot of platforms in DevOps, right?
Okay. So general term is used as DevOps engineer. If you are working with different tools, okay, the tools which we have talked about, the general terminology is like DevOps engineer, DevOps consultant, and so on. Yeah, if
Okay.
you go into more specialization, we have the designation like platform engineer, SRE specialist, and so on. Yeah.
So, sir,
If,
you will teach about the whole DevOps concept. You will
yes.
cover
So
all the.
so yes. So DevOps is all about hands-on. It is not about theory. Okay. We will focus only 20% on the theory, 80% on the hands-on. Yeah.
So there is a lab, for the DevOps.
There will be a lot of labs which we are going to do. There are a lot of things which we are going to do as part of the DevOps course.
So we
Yeah.
will get the answer.
Theory is just to actually explain you the concept, and everything will be practical.
Okay. Thank you, sir.
Okay. Yeah.
What kind
Any,
of project we will get
I'm not able to hear anything, Rishabh, what you have said.
what kind of project we are going to have?
Can you be little closer to your mic if you are speaking like on a speaker phone?
Yeah, saying what kind of project we are going to have?
Yeah, we are going to do a lot of projects in terms of building the complete CI/CD pipeline using Docker, Kubernetes, Jenkins, Git. Yeah, we will have a major project where we are going to create a complete clone of a, let's say, Netflix website. The projects will be like that. Yeah. Again, because there are so many things to cover, and within a very short duration, your cooperation is very much needed, because whatever I am going to tell you to complete as part of the homework, you have to finish it off. If you don't finish it, it keeps on piling, and then you will not be able to cope up with the things which we are going to do in the next classes. So doing it on the day when I am telling you to do something is very important. Practicing it out rather than just memorizing it will not help. Practicing is the key in the DevOps.
Daily how many hours, sir, session?
1 hours, 1.5 hours. Okay.
So there will be recording sessions will be given to us.
Yes, there will be recording of that. You can reference that.
And the materials, any documents?
There will be some materials
Okay.
which will be as a part of the LMS. You will have that access to the LMS. You can use it from there.
Okay. So we will be get full confidence in DevOps after the coaching, right? Including
Uh,
our this.
yes, you have to put some
Yeah,
extra
yeah.
effort. Yeah, I mean, my efforts are only 20 to 30%. Okay, it is your rest of your efforts. If you don't do the practice, if you don't do whatever I am telling you, if
Mm.
you don't do it multiple times, then nothing will help. Yeah, you will forget what we have taught in the first session. So
Yeah, got.
okay, fine.
Because I have around 3.5 years of experience, I need to move
Huh.
to the cloud. So
Okay,
that's why.
okay. So
So
people who, yeah, means we will need some exposure to the cloud as well. If you have a basic understanding of the cloud, that will help you. We are going to take one of the cloud, means little basic of the cloud, but then again, it is understood that you should have some background of the cloud to understand all those things, whatever we are going to do.